In this video, we are going to pick up where the last video left off. In other words, we're going to look at how you take an indeterminate and a ring and start to build polynomials, and how we build addition and multiplication of polynomials, all from a foundational point of view. As in the last video, we start with letting R be a ring. And this is going to be our base ring, which is where our coefficients are going to live. So our coefficients are going to lie inside the ring R. We are going to let X be an indeterminate. And in the last video, we learned what that meant. In particular, X is not inside R, and X doesn't break any of the standard ring axioms. And as we use them, I will point them out. What I want to do in this video is I want to define a polynomial in X over R. So a polynomial in X over the ring R is any expression that looks like this. And what does this expression look like? Well, it looks just like a polynomial from high school. an times x to the n, a plus an minus 1 times x to the n minus 1, plus a sub n minus 2 times x to the n minus 2. And you keep reducing the powers of x until you get down to a1 times x plus a0. And this is where the ai's are all from my ring R, and an has to be different from the 0, because I want this first biggest power to not be equal to 0. And following high school, we usually call this thing p of x. Now, there's a bunch of vocabulary that you know from high school that is applicable to this particular polynomial, and that's what we're going to go through next. So when I write p of x is equal to an x to the n plus an minus 1 times x to the n minus 1, and so on until we get down to a1 times x plus a0, there are things that I want to point out. The first one that I want to point out is that the biggest power of x that's actually present is an important term. And we're going to call that the leading term. Or we can call it the highest order term. But in this particular example, it would be an times x to the n, and an cannot be equal to 0 in order for that particular stuff to be defined. The leading coefficient is just the an, which lies inside the base ring R. The degree of the polynomial, which is usually written as just degree of p or degree of p of x, they are both used. And that's just going to be n, which is the highest power of x that is present inside p of x. And then there's one other thing that I want to talk about, and that's the constant term. The constant term of p is the last guy, the one who is not multiplied by an x. He's just a sub 0. And it is frequently the case that we can abuse the notation slightly and think of a sub 0 as being a sub 0 times x to the 0. In other words, we'll use x to the 0 as if it is a multiplicative identity, even if R does not happen to have a multiplicative identity. If R has a 1, then it is customary to set this symbol, x to the 0, equal to that 1. But we abuse the notation even when R doesn't happen to have a 1. So now that we know what one polynomial is, we can actually look at the formal definition. R square bracket x is defined to be nothing more than the set of all polynomials over the ring R. Now, it's important to note that this is R square brackets. X. You have to use square brackets around this guy. R round parentheses around x is not the same thing. We probably won't talk about this guy in this class. We'll only primarily be interested in this. And R square bracket x is the set or the ring of polynomials over the base ring R. So he's usually pronounced either the ring of polynomials over R, or he's pronounced R square bracket x. That's how you read this guy. And he's just the set of all polynomials over R. Now, you'll notice that I said that this guy is a ring. So the question is how is addition and multiplication defined on R square bracket x? Well, it's defined exactly how you define it back in high school. So for addition, you simply add like terms. So if I have ax squared plus bx plus c, and I want to add dx plus e, I would be saying I get ax squared plus b plus d times x plus c plus e. And so that would be what adding like terms is. However, it's important to note that whatever arithmetic is being done on the coefficients, the coefficient arithmetic is done inside the ring R. So as an example, if I let x cubed plus 5x squared plus 3 be in z7 square bracket x, in other words, this is a polynomial where the coefficients are in z7, and I want to add to that 3x cubed plus 2x squared plus 5 inside z7 square bracket x, the answer would be 1 plus 3 x cubed plus 5 plus 2 x squareds plus 3 plus 5 as my constant term, but this has to be inside z7 square bracket x, so I have to do the addition mod 7. So that means I need to reduce each of these things mod 7. So this is going to turn out to be 4x cubed plus, well, 5 plus 2 is 7, that's 0x squareds, plus 8, but that reduces down to 1 inside z7 square bracket x. And 0 times x squared would be a 0, so we just get 4x squared plus 1 would be the sum of these two polynomials. Multiplication is defined using the distributive law. because we don't want to break the distributive law. So in other words, if I've got something like ax plus b, and I want to multiply it by cx plus d inside of a polynomial ring, we basically have to do the distributive law twice. First of all, we fix an element on the second part, and we rewrite this as ax plus b times cx, and then we have ax plus b times d, and then we do the distributive law a second time. We have ax times cx plus b times cx plus ax times d plus b times d. Now it's important to remember that the x's commute with the elements of the ring, so we get ac x times x, which would be x squared, plus bcx plus adx plus bd, and then we add like terms together. And so we have bc plus ad times x as that middle term. And again, it's worth pointing out that the arithmetic in each one of these things with the coefficients has to be done inside the ring R. So it's done in ring R. So again, as a quick example, if I have 3x plus 1 times 2x plus 4 in Z7 square bracket x, that's going to be 6x times 2x is 6x squared plus 2x plus 3 times 4 is 12x, and then we get a 4. So we have 6x squared plus 14x plus 4, but this is in Z7 square bracket x. And in Z7, 14 is the same as 0. So this is 6x squared plus 0x plus 4. So the final answer would be 6x squared plus 4 inside the polynomial ring over Z7.